Hi all. So today we are going to focus on our workflow for the plaster model, and that basically relies on curves and lofting. So basically we'll go on between curves and surface tools, and we'll add a bit of editing point elements, but that's how we'll proceed. So we'll start getting all these kind of effects, and we'll start from now. So from now we'll start it like try to model something simple on that, and that basically try to model that kind of bulging form of the plaster. And you can always start with this simple form, and then we'll start even more complex forms and geometries in order to see different workflows and results. So we'll start now. I'll turn it off, these ones, these two, and basically start coming up from a normal line. And if you have something that's based on your plaster model, so it's something of that the weight is brought down the plaster model, basically it's coming down on that kind of a form, curved form, and that's how you after being dried you flip it through. So basically that's what we could try to calculate. So we've been using a lot of polylines. Now we can actually start using the curves. So there are two types of curves. There's the curve through points, which is this one, and which basically every time you click averages the points in between, and you actually see once you turn it on, you actually when you select it, you see that average happening, and you can actually move it around and reshape the form. This is one curve, and the other one is the interplayed curve, where actually every point you click on, basically it passes through it, right? So there's two different types of curves, and once you click on this point, you'll see that the average is here, but if you actually want to calculate and move the actual points on, you put edit point on, and you can start selecting points on the curve itself as well. Okay, so that's basically the two types of curves that we are going to focus on and try to model that kind of bulging element. So imagine that it's upside down, but in this case we are just, once you rotate the model, you will start modeling like that. So, and because we are going to start doing it standing up, I'm going to immediately start using the front view in order to start drawing that curve. And what allows this to do, this kind of interpolate curves, what shows you is once you have these elements, and you can, again, the best way to do it is actually taking a photo and trace it, and let's say, okay, I got my form. One of these forms will be this one. As you can see, once you design the curves, you have all these points and become very curvilinear, and that actually comes every time you design any curve, in this case, or even the interpolate curve. Let's try to see only one element. You start seeing here the degree number 3, right? So that's what we want. I'm going to turn on my cursor on. So this is number 3. The difference between that, so I'm going to click it here. If I want to select this curve, and if I'll do it, so this is the degree curve, right? But if I say it to 1, what's going to happen is going to become a polyline, right? So if it becomes 2, it's an average point curve, and 3 is the interpolate curve point. So basically, that's what the difference might recur to, right? So in this case, we are using a 3 element because you want that curved element, so the degree is 3, and you saw that already in the rebuild before. So I'll start with something simple, something that goes like that, and not really symmetrical or anything, and obviously you start seeing that it draws there. What I'm going to do is do another curve that's similar, that might have the similar shape, but it's not so bulgy, let's say, but a bit more condensed to the other side. And you see, it's always design laws draws on top of that line, and I'm going to, if you know the dimension of your model, great. If you don't, you just you start again, bring a photo, bring the picture in the bitmap, and you start analyzing it. And I'm going to add another curve to it. So and this one is going to be on the other side, and like that. And again, I'm going to bring this one to the end, and one more curve, which I can even almost bring it back up. Actually, bring it back up into this kind of element. That's it. So actually it didn't go up because, as you can see, it snapped the curve, so that's not a good element. So let's start, and don't snap to anything like this. It will curve it. So a more symmetrical one, and that will be the last one. So basically what we need to do is connect these curves, and we briefly went into the previous model on the stick model. We went through this command called Loft. So if you go to Surface Tools, you have this command called Loft, which is this one, which allows you to connect all curves into one big surface. So select Curves to Loft, click, select them, press Enter, and it creates this, right? So now we have already a problem here. So this is interesting because it allows you to, it's not that something wrong with the curves, it's something that we did wrong, actually. So all curves have a start and ending point, right? Start and ending point, start and ending point. So where you actually choose that starting and ending point is while you're selecting the curves. So if I selected this curve starting point here, but then the ending point, the next one, the first point when I selected here. That's why it tried to bring the starting point from here to there, and that's why it brings that kind of twist into the surface, right? We can actually arrange that, align curves, and you'll see that starting point, and then it's shifted to here. Actually, I want the starting points to be always on that side, so you click on those points, and then you start having, yep, that's correct. So that was the form that I want, right? So we can fix that, and then there's different types of lofts. There's the loose, which kind of averages it. So in this kind, it doesn't touch these curves, as you see, versus the normal one, which is averages it, but it's a bit more accurate. There's the tight, which is very, very even more precise. The straight sections basically connect straight lines between the curves, as you can see here. And the uniform one at the moment is just similar to the normal one. So that's what would go. So that's what the normal one would do. If you want to close the loft, so basically that creates a curve inside. So it straps around, but again, be careful. It might create weird shapes. As you can see, self-intersects, not ideal. In case you don't want to close a loft. And also, you can, if you don't want to simplify, you start seeing these curves. The reason why this isn't even like it was before, it was because some curves might have more points than others. So these curves were done with 3 points, and this one I made it with 4 points. So that's why I started having this uneven kind of ISO curves on the surface. So you can actually rebuild with everything, and every curves will have 5 points of definition, and then you have a very smooth and clear surface. So this loft is fine. So this is one that can create that kind of a surface. Now, if you want to add on so I'm going to hide this one. I'm going to put it into layer 1 and turn off layer 1, and just really combine and use this curve. So I use copy and drag them here, and start modifying them to see that kind of element that you can actually start doing. If you want, if for example this has this kind of kink, so kind of breaking point into it, into this you want to divide it into kind of two tunnels almost, you can add into the curve, you can add a kink. So it's called insert kink, and everything is on the curve tools actually, and then select curve of surface to insert kink, I'll say that, and then you'll allow it to actually put it. You can turn on, if you want to make it in the middle, it just snaps to the midpoint, and perhaps that's what I want to do. What this allows it, just you see, it's another point on the curve. What allows it to do is once you select that point, press enter when done. You can select more than one. Now every time you select on that curve, and once you zoom in, you see that there's a point here that's very close to the other one. So what if you want to move it around? So you see this is the control points. It's not the kink is that one. So this just keeps on controlling that, but it creates a break into that curve. So it allows it to create a kind of an edge or a vertex that will start another curve, but it's a connected curve. So I'm going to undo, and actually what I want to do is move this one downwards. So in this case, I'm going to move this one, and it will create kind of two tunnels, right? So if that's the case, again, one thing that you need to be careful is how many points this have. 1, 2, 3, 4, you see? And in order to visualize the points, again, you put edit points on and select all the curves that you want to select. Press enter, and you start counting. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3 points. So that's not, and then there's this one who has even more. So what we need to do is actually rebuild these curves according to the maximum number of points to give more definition to the surface. So if this is the one that has more points, 1, 2, 3, 4, 5, 6, 7, 8 points, right? So all of them, we need to actually rebuild these ones with 8 points as well. So rebuild. And why do I'm rebuilding the curves and not the surface? Because like this, I won't lose that kink. If I rebuild these curves, so point count 30, I actually want 8 points. The degree is the same, delete input, rebuild. So basically there's virtually almost no difference. But now you can see you have more points into the more control points. So edit point on, see, and so you can start controlling. So if you want to make this a more even kind of element, or you can start calculating or manipulating this curve as you want, right? And so that will allow you to a lot of controls, and in case the draping of the plaster went that way. So I'm going to loft it again, and let's see the results. So again, always choose the loft from the same side. You can drag and see, but if there's a twist, you already know what's happening. So in this case, you see the kink doesn't have a total reflection because it averages it. Let's make it tight. And yeah, it doesn't allow you a lot because I'm rebuilding with 5 points. Actually, I do not want to simplify. And this, if I don't want to simplify, you see, all the lines are still straight, the ISO curves, and it allows you to have an accurate outcome. Okay, so I'm happy with that. So this is loft, and this is one way of having these kind of surfaces creating double surfaces or even more. Okay, so another way of actually, which is similar, is the evolving from a network of curves, which is this one, which allows you to create the edges of that plaster model. So if you can only trace the edge, perhaps this would be a easier element. So, and that's what we are going to do. I'm going to use exactly the same curves, but I'm going to move them around I'm going to put this one into our layer 1, I believe, and create these curves, copy, and in order to show you, if you want to design along with the network of curves. So that, for that, to some extent, focusing on that. What you need to do is to basically what you need the edges of the curves. So not like a tunnel, it needs the edges of the curve. So that's what we are going to do now. Basically, I'm going to rotate these curves. Oops, I wanted to actually replace this one with the one of the kink, this one, to show you more complex results. There we go. We brought this one in. Now what we need to do is, because we are all actually only drawing with the edges of our surface, so basically what we need is to align these things there. So you can actually rotate the curve, rotate, and this, press enter, this one, pick this one, and press rotate, and then move the curve again. And here, look at there. So now we'll move this one there. This one is already moved there. And that's that. And now we have this little one that needs to be obviously rotated and stretched towards there. Or it needs to be modified according to that edge. We can also, if this is not a perpendicular kind of model, we can rotate this curve as well and show that, okay, no, it's actually not a perpendicular model. It's going to be something towards this, whatever angle might be, and that since from the top view, and start aligning this curve there. So rotate. You can rotate the curve and closer to that element. And now what you can also do is orient the curve. So orient, it just snaps it to this orientation, and that's what we are, it's a type of orientation, but it aligns it immediately with the edge points. So select objects to orient, press enter, reference point 1, which is this one, and reference point 2 is this one, I believe, and target point 1, orient, select objects, press enter, reference point 1 is this one, reference point 2 is this one, the end one, and the target point, so target point of this one, of number 1, is this, and target point of number 2 is this. So it immediately lines up with the element. Obviously, because it's too short, doesn't add up, but we are going to basically move this point, create that point, and use the edit point on, select that point, and actually snap it to that, and also move this. You can move it around. And in order not to be flexible, and again, it can break it. It doesn't need to be a straight line. It's up to you. And the same thing on this one. If you want the gumball to use it, let's bring it a bit more towards this area. And the same with that point. I'm going to make it a little bit higher. So again, so let's go. Hopefully, this will be similar, and we'll continue. So similar to Loft, but instead of having a linear path, is the network of curves. This one, surface from a network of curves. So select curves. So you select it generally in order 1, 2, 3, and 4, and press enter, and it gives you this kind of complex result about the geometry. I'm happy about it with the elements. So this gives you one form of actually doing this curve, this kind of inverted plaster type of modeling. Now I'm going to put this one in this layer 1, and I'm going to use another one and just the final model to show another case, and copy and press it here, and show it as well. How can it be done with other elements here on the surface? So there's also this sweep to rails. So basically sweep to rails will allow you to ask 2 rails and then 2 cross sections in order to divide to model it. So the first rail, let's say it's this one, the second rail, so they always need to be in the same direction. That one there, right? Always in the same direction. Could be the other 2 if you want. And then the cross section, sorry, I forgot to put the cross section. So those the rail 1, second rail, and then we'll ask you for the cross section. So anything that forms the cross geometry, and that's what we are putting here. Pressing enter, and again, what you see, it gives you also the same kind of outputs, but be careful again with intersections. It's already can see there's some more of weird kind of geometry, self-intersecting, so you can always try to rebuild it. Again, it averages, be careful with the kink, so if you want more definition, you just increase it to, let's say, 30. And yep, and let's see. And it allows you that because we select on this way, it allows you to do this, and refit. You can also select refried cross sections that allows you to reorient your geometry. In this case, perhaps this would be the best way, or yeah, this would be the best way actually to reveal the cross sections, and and you can sweep it. So this is one form, and I'm going to turn on all the ones that we did, and this is the channel loft, with a kink on this side, and then if you this is only kind of two-dimensional, which is a corridor in a way, and these ones are the networks of curves, or the sweep rail, which actually you design through the engine using the boundaries here on the left and the right. So this is one. This is a workflow in order to try to emulate our plaster model. Thank you.